Okay, so now let's understand about that. How do you basically enhance your RAG system? Okay. Before this, I just want to give you a little glance about that in the last lecture and while implementing the traditional RAG, right? So this is just while we were creating the chaining, right? So this you need to pass the retrieval as a context you need to pass in the chain. Okay. That after this only you can actually like go and test your LLM model, right? So before that you need to create one chain, right? So inside this chain you need to pass this retrieval as well as the runnable pass through, because user is actually asking a question and the entire thing is supposed to packed inside the chain. Okay, so that whenever you're asking a question, okay, this is your chaining operation. So like whenever you're asking a question you can actually ask, right? So this I wanted to tell you. Okay, this I actually like forgot to tell in the last lecture of traditional RAG. So this I wanted to tell you that you need to pass the context as well, right? Now let's come back to the how do you basically enhance the RAG system. Okay, so in this notebooks we will be approaching by RAG enhancement by including the topics of hybrid method. Okay, so we will be creating the sparse embedding as well as the dense embedding. Then we will be introducing the cross encoder model. Okay, the cross encoder re-rankle model. And then we are actually setting up the hierarchical search, right? So we have covered all this theory part. Now let's understand about the implementation part. Okay, and these are just a use cases and just overview of RAG. Okay, so let's first import. These are the necessary libraries which I need to import. First is quadrant vector storage for vector storage, fast embed sparse for creating a sparse embedding, and then there is a retrieval mode, okay, for creating a retrieving agent. Then again for creating a client so that you can actually connect with your quadrant vector db, you need to import the quadrant client. Okay, and after that few of those imports are necessary needed in order to install this fast embed gpu. Okay, then let's first import the sparse embedding. Okay, earlier what we were doing is that we were using the OpenAI embedding model. Okay, so that embedding model is supposed to do what? Supposed to create a dense embedding of my chunk. Similarly, in order to create the sparse embedding, we can actually like use this model PM25 as a creating embedding in a sparse matrices. Okay, so this is just a sparse embedding model. Okay, and then this I'm actually supposed to create one vector store. And what is this? What is this embedding? Just think about this. This embedding is basically your OpenAI embedding, okay, which I have already imported in the earlier section of the traditional RAG. Okay, so this embedding is basically, what is this? This embedding is basically OpenAI embeddings. Okay, which model that we were using? We were using the text model, right? The text embedding model. Okay, and in order to enhance your RAG, I already told you in my theory class as well that other than using the dense embedding, you need to include the sparse embedding as well. Okay, so that simultaneously you wanted to store the embedding of the chunks. Okay, because chunks and other part we have actually created like in the previous one, right? In the previous notebook. So here only few things I need to change it and give it more suggestively. Okay, so here I am just adding the sparse embedding. Okay, and then these things are as same as I already showed you in the previous one. You just need to add the hybrid method. So previously you were using the dense method, right? See, in the previous section what you were using is that you're using the dense method. Okay, and these are the simple dense embedding that you're using. What I have done is that I have just imported or just like included one sparse embedding, as well as instead of dense embedding I am actually using the hybrid embedding. Okay, the same thing here I am actually supposed to use the same thing. Okay, so let me create. Okay, I need to define the chunks. Let me define the chunks as well. Just a second. So this part is over, this part is over. Let me define the chunks, right? So for that I need to import my some data, right? So I think these are my data info.txt. This we were using. Okay, let's create a chunk. Split these things into a chunk. Okay, now I think my chunk is created. Now let's use this thing. Okay, now my chunk is created, so I am actually giving my chunk and embeddings. Okay, embeddings I need to also check. I need to create the embeddings as well, right? Because this notebook has been like off for a day. Let me create the embedding as well. So this is the, okay, embedding is already created. Good. Now let me use this thing. Okay, now as you can see that in my vector store all these things are getting saved. Okay, in the collection name as verify enhanced rag. Okay, so there is a collection, it will going to create or already created collections verify enhanced rag, and all these things will getting saved in my cloud storage. Okay, so if I just go and check, if I just go and check this one, and you will see that my embedding has been like created. Okay, the verify enhanced rag, this one, right? And inside this as you can see that it has what, it has total 3072, the size of the entire vector, like the vector space. And then it is actually using the cosine as a configuration in order to do this similarity check. and then it is also creating a sparse matrices, okay, as well as the dense matrices. So if I just go inside this, so you can actually see, okay, you can actually like see the searching quality. You can actually also visualize the graph as well. So there are so many other things is there. If I go to graph, many more functionality, but I think we only will be focusing on here. Okay, so if I just go and check, you can actually check these things, right? Now let me move back to my notebook. Okay, so this is my vector store. Okay, and this actually I'm creating on retrieval. Okay, retrieval is like it will going to retrieve the top 6 result. Okay, now how do I actually enhance my RAG? So because I have already like used the hybrid as well as the dense embedding method. Okay, I have actually used the hybrid search as well. Is there any other thing that I need to include? Yes, we will be including the cross encoder. Okay, cross encoder at the very last stage. Okay, so that when the retriever is going to retrieve, let's say, top 6 element, okay, it will go to the cross encoder, and cross encoder will supposed to use the re-rank matrices, okay, in order to fetch or filter out more relevant data. Okay, so for that, what I'm supposed to do is that I will be like retrieving the contextual compress retrieval. What does it do? I will tell you. Okay, first of all, just see the import part. So what are the other things that I need to retrieve? So from the LangChain classics, I will be retrieving the cross encoder re-rank. Okay, I will be importing the cross encoder re-rank as a method, and then from the LangChain community, I am going to import the Hugging Face cross encoder. Okay, now what I'm supposed to do is that I need to first include the cross encoder model. Okay, from where? From the Hugging Face repository. Okay, why? Because it is actually a BERT based model. Okay, so for BERT based model, there is a two way. Okay, first we can actually use the API in order to access the BERT based model, or the other thing is that we can actually import the BERT based model from the open source repositories like Hugging Face. Okay, so I already implemented these things, so I have already included, it is already present in my model. Okay, so now my model is actually containing what? My model is actually containing the cross encoder. Okay, now let's try to sum up everything. Okay, so in order to sum up everything, so this I am actually using the cross encoder re-ranker, which I have actually imported. Okay, now what does it do is that first of all, it is actually going to use the contextual compression retrieval. Now what does that mean? It means that earlier, whatever the retriever that we were using, okay, that retriever, see in the previous, in the traditional RAG, right? If I just go to this traditional RAG, whatever the retriever that we were actually using, okay, that retriever is just like using the encoder, okay, like the OpenAI embedding, okay, and the other components which were relevant to the vector storage, okay, and then we were actually creating a simple retriever. Now here what we were doing is that other than using the base retriever, okay, other than using the base retriever, I am also attaching this re-ranking, okay, which is actually like present in my cross encoder. Okay, and I am actually using this method so that this will going to compress in the compress retrieval. Okay, and the rest is actually the same thing. Okay, the rest is actually same thing. So again, so I'm actually defining the prompt, okay, and I'm defining my LLM model, and here also in the context, instead of giving the retriever, I am giving the compress retrieval. Okay, why? Because this is my main retrieval. Okay, it is actually containing the two things. Okay, the first thing is that it is going to contain my encoder embedding model. Okay, so that all this embedding model is getting stored into your vector database. Okay, and the second thing is what? Second thing is, at the very, like, once the base retriever is going to retrieve, let's say, top 6 element, okay, then it has supposed to go to the cross encoder model. Okay, so that inside the cross encoder model, it will filter out more. Okay, so if you just go here and check, right, so I'm actually like filtering out of 6 retrieved chunk, okay, by matching the cosine similarity. It is supposed to feed it into the cross encoder, and out of 6, the cross encoder re-rank all these 6 element, and it is going to take the top 3 element. Okay, top 3 element. So that is why I'm just passing these top 3 element here, okay, in my LLM as a context. Okay, based on that, I will be asking the question. Okay, so again, the same thing, I'm actually asking a question, okay, and it is supposed to give me the response. Okay, so that is how, like, you can basically like enhance your RAG system. Okay, just like in traditional RAG system, you were also getting an answer, but in enhanced RAG system, you will going to get the answer which is much more related to more relevant answer. Okay, the answer would be more relevant. Okay, as you can see that the list out the limitation of AI surveillance on the camera action, like which activity it fails. So it is saying that it is not specify the passage only described. So it is actually like understanding the data. It is not in always in a urge to give you data if something is not present in the document. Okay, see, most of the LLMs make a mistake. What it do is that, suppose if you're actually asking a question, right, now suppose the LLM does not know the answer, right, it will not directly tell you that it will not know the answer. Okay, it will anyhow try to give you an answer, and you will think that this answer is correct, but the answer is already mixed up. Okay, the answer is like kind of manipulated, the hallucinated. Okay, that is why, if you are getting this right, see, it is clearly telling that no activity category are listed, and these things you are not getting in traditional RAG. These things are you're definitely not going to get the traditional RAG. Why? Because most of the LLM system is anyhow try to are trained in such a way so that it is anyhow try to serve the user by adding some of those keywords. Okay, and user may probably think that this answer is correct, but actually this answer is not correct. Okay, because whatever the user has actually asked the query, right, that query may not be possibly present in the database itself, right? So that is by enhancing these system, right, that is by enhancing these system will make your answer much more in a credibility, in a zone of credibility where you can actually trust your model. Okay, by like using these kind of approaches, by adding the two layer. Okay, the first layer is like by using the re-ranking layer. Okay, and the second is like by using the sparse and the hybrid search method and other thing. Okay, so in this way you are supposed to enhance your RAG system. And regarding that which algorithm like it is used for searching, so I will be using this hybrid search. Okay, so that is why I have just intentionally like took this quadrant vector store. Okay, so that I don't need to explicitly define that which algorithm I take. Okay, it is by default taking the best possible searching algorithm. Okay, whether it is linear, binary, KNN search, okay, the hybrid search and other thing, it is taking the best possible search in order to retrieve your data. Okay, so this I wanted to show you that how you can actually like enhance your RAG system. Okay, I hope that you will get it. Okay, so this is how you basically enhance your RAG system, and you will try to make the same chat based model by yourself. Okay, so yeah, thank you.